cinema projectors at Seiko Epson Corporation in Japan. Indeed, we believe that performance for a high-quality image is the most important factor in any projector. Over the last decade, we have perfected our 3LCD technology. It has become so successful that it has become the industry benchmark. We have also developed many other innovations that give Epson projectors the brightest and most color-perfect output on the market. And we are always pushing for the next technological step. The products we are introducing here today are outstanding in their 3D performance, clearly setting our technology apart. First of all, they use new HTPS panels with crystal clear fine technology made by Epson itself. This means they are inorganic and normally black. What makes these new panels so special is the refresh rate. It's 240 Hz in 2D mode and 480 Hz in 3D mode. This helps achieve natural 3D projections, as I will explain in a minute. But before I tell you in detail about our 3D images and the technologies that we will bring to the market, I should first explain some of the challenges we have been working to overcome. Picture quality is one of 3D's greatest challenges. The issue that manufacturers face is a loss of brightness when projecting 3D images. This means dark scenes in films become difficult to view and the detail of the picture is often lost. This is a consequence of what is called crosstalk, the ghost effect caused by the switch between left and right eye images. There are many factors contributing to loss of brightness in 3D. Active shutter glasses are often used, and these affect the color and brightness of the pictures. When the images switch between left and right, light is lost. Responsiveness and transmittance of 3D glasses are also factors of light loss. As picture color changes after passing through 3D glasses, we have to correct it. And this correction also leads to loss of light. So Epson has developed a new technology that suppresses the light loss in this process. This illustration shows how 240 Hz LCD displays 3D pictures. The picture for one eye is drawn twice on the LCD. And the 3D glasses are synchronized with the LCD like this. The LCD panel is refreshed through a line sequential method. Therefore, each frame is drawn from top to bottom, and the glasses are synchronized with it like this. But there's a problem here. When the LCD is refreshing from one eye to another, right and left pictures appear simultaneously in the frame, like a double exposure. Let's see this phenomenon in a timeline. It takes 1/240th of a second to draw one frame from top to bottom. So when the LCD refreshes, both pictures are visible at the same time. This is perceived as crosstalk. In order to hide the crosstalk every time the LCD refreshes to show the image from other eye, both lenses are blacked out. This leads to a big loss of brightness. So, to address this issue, Epson has developed a 3D technology which has enabled us to double the refresh rate from 240 to 480 Hz. This reduces the blackout period a lot. In order to do this, we had to develop a special driving method for the 3D mode. Thanks to this new driving method, we refresh the images twice as often. It works like this. In the normal 240 Hz drive, one frame is drawn in 1/240th 40th of a second, and the same picture is drawn twice. In the 480 Hz mode, first, only the odd lines are drawn. This means that the data volume is halved, so it is possible to draw one frame in half the time. In the next step, only the even lines are drawn. In this way, the 1080 picture is completed in 2 steps as in interlaced scanning. This process is then repeated. In both cases, it takes 240th of a second to complete the full HD picture. However, we have reduced the blackout period with this driving method by almost half. Let's look more closely at the blackout period. The bigger angle represents a longer blackout period. As you see, with the 480 Hz drive, the blackout period becomes much smaller. This lowers the flicker rate and allows users to see brighter 3D images that are comfortable to watch. How much brighter? We have improved brightness by around 70% compared to the 240 Hz drive. What's more, our flagship projectors also enable you to convert full HD 2D images into full HD 3D images, as you can see in the diagram. Though the process might seem complicated, the simple press of a button converts 2D high-definition films and video games into natural high-definition 3D projections. As part of this process, when a 2D picture is fed into the projector, it is analyzed by the 2D 3D conversion IC chip and split into various levels of depth. The IC then rearranges them to create depth. This process is crucial to create natural 3D images without any sense of discomfort for the viewer. In the next step, all objects in the 2D picture are separated and an embossed model is generated for each of them by combining the depth configuration with the embossed model information. Parallax images which simulate both the left and right eye views are generated. And then the images are combined and projected as 3D pictures. In real time, it is easier than it looks, though it's no mean feat. Epson has succeeded in creating the perfect set of technologies to generate truly natural 3D pictures. Watching a film on an Epson 3D projector gives the same natural 3-dimensional view as the one you would get from your window. All these technologies together, our new HTPS panels enhance the brightness through our new 3D technology, and the great 2D to 3D converter ensure a perfect performance. So let me hand back to Valerie-san, who will explain to you how we are bringing simplicity to life.
Le mettre qui est